Today is part 3 of our MKS Skipr board install. Today we're actually going to get the board configured and running a 3D printer. Hello everyone, Chris here. Yes, it's been a long journey with us getting our MKS Skipr board installed, but today we're going to finally get it working on our 3D printer. Now officially there's been 3 parts to this series, but we've also taken a lot of side trips to get other features implemented on your Klipper install that you might want to take a look at. So there's a lot of videos that we've done on this. But today we're going to be focused on actually getting it cabled up, getting it working hardware-wise, as well as that Printer.CFG file that's synonymous to Klipper. Now this isn't going to be a deep dive on every subject. I have other videos like auto bed leveling and sensorless homing that you can use for detailed information on it. I'm going to hit the highlights on a lot of that. Mostly today I'm focused on getting the printer up and working, getting the motors turning in the right direction, getting the printer configured as it should be, just to give you the base install of how a printer like this should be configured, and a lot of what those items in the Printer.CFG mean. So first thing we're going to do is take a look at the hardware. We're going to try to get some information off of our old board we can use on our new config, and then we'll move to wiring this whole thing up. So this depends on the printer that you're using. Today we're using the Second SK Go. It does run Marlin, and it runs a Big Tree Tech SKR 1.4 board. You'll see that more in a moment. Marlin, you can go in, if you cable up USB, you can run an M503 command. This is going to give you a lot of the information that you need going forward about your printer, so we can carry that over to Klipper. So I highly suggest you do this if you're running Marlin, and just go ahead and copy and paste all of these values into a text file. This is going to save you a lot of time while you're setting up your Printer.CFG file. If you're running RepRap on your 3D printer, you can go into the web interface and pull the configuration from there. So here's a look at my current SK Go setup. Buried underneath all this mess of wires is a Big Tree Tech 1.4 board. It's a fine board, but that's not the point. We want to install our MKS Skipr here so we can utilize Klipper. You could run Klipper on this, but you get the gist. We're working on the MKS board now. Now, there's a lot of mess going on here, but with this printer, I'm currently running the Pico hot end. With the Pico, you only get 5-volt fans because they're very small. So I have a buck converter for the hot end fan, I believe, and then this power regulator over here that actually comes with the Pico to run the part fan. They run at 5-volt. Again, with the new board, I just have to change a jumper to run at 5-volt, so I won't even need all this. So right out of the gate, that's going to make for a cleaner install. This is 24-volt. I do have an AC powered bed. None of that's going to change. I just wanted to give you that information up front. So I'll get started taking all this off, and then I'm just going to drill some holes here in this ACM to mount the new board. It is quite a bit larger. Remember ACM, it is conductive, it's aluminum, so if you're going to mount a board on that, you're going to need some standoffs. So I'll get all that work done and we'll come back. So we've got our board mounted. I had to switch out some of the connectors just based on how the SK Go was wired before, but mostly this one is just JST. You have some blade connectors and then ferrules up here for the heaters. You'll see that as I install it. The first thing I want to do though is make sure that all of my fans are the correct voltage. I'm using 5-volt fans for everything so far. I just have the hot end and the part fan, again 5-volt, but I'm going to switch all of these to 5-volt just in case I were to plug one of these into the wrong port. I won't blow it up. So I'm going to start at the lowest voltage possible. Looking at the schematic, this jumper right here, this is the one it has on by default. This sets your fan voltage to voltage in, so whatever your input is. So in this case, it would be 24-volt. The one in the center, hard sets it as 12-volt, and then the one on the far end is 5-volt. So I'm just going to move all these to 5-volt. So there we go. Now we're safe, and we know we won't overload the fan. And I want both of my fans, again I only have 2, to be G-code controlled. Your part fan is usually listed as fan 0. And that's this one right here. These are the 3 that are G-code controlled. These are always on. So I'm going to put my part fan right here, and then the hot end fan will go right here. I'm going to set that to be thermally controlled somewhere at 70 C, so it'll come on when the hot end heats up, but it'll be off when the printer's not running. And we'll just stay put here. We're going to go ahead and plug in the hot end heater over here. This is heater 0, so we're going to utilize that for our hot end. Again, I have wire ferrules on these. So our hot end's good. We'll move down a little bit and look at the thermistors. Thermistor 0 for your hot end to go with that heater goes right here in the bottom one. And then on the other side of that bank, that's the thermistor for your bed. So we'll plug that one in as well. Then these here, these next three, those are the negative end stops. We're using centerless homing for X and Y, so we don't need those two. And then Z-min, I am using a probe. If you're using a probe, make sure it's correct. It's very common on the inductive probes to be wired like this. Brown positive, ground is blue there in the center, and then the signal pin is black. And that's how this board is configured. Just double check. You don't want to short anything out. But remember those top two, X, Y, and Z-min is where I like to put the probe. It's just easier to configure that way. This one does have a thermistor on it. It's a pin to 2 probe. I don't really see any use in that. We might be able to configure it, but I'm going to leave it unhooked for now. Also here, right underneath that, I've got an end stop switch for filament runout detect. I want to put that right underneath it. And then we can start looking at motors. We have X, Y, and Z. There's 2 parallel plugs for Z. This is a Core XY machine. Most of the time, X is going to be your A motor, Y is your B motor. If you have the motors in the back of the machine, the most common configuration is A is on the left, B is on the right. Now, that could differ between a lot of machines. A lot of these machines have the motors in the front, so your configuration might be different, but on mine, we're going to put the A motor in X, B motor in Y. And the next one down is Z. I only have one Z motor, so I'm just going to plug that into the top one there. We'll leave the next one open. Again, that's another additional Z motor, and we'll plug in our extruder motor and the one next to that. Remember, you have 4 options there for extruders, but you can use them for whatever you want. So there's all the motors. On this board, we do have EXP1 and 2 down here. I have the 128/64 screen, that full graphics display, the old rip-wrap style. I'm going to go ahead and plug it in. I'm not hopeful that it's going to work. We'll try to get it configured. I'll have to do some research. That might be an add-on video. But let's go ahead and plug it in. Why not? EXP1 on top, and then EXP2. And the last 2 things we need to worry about are the power in and the heated bed. I already said this, but my heated bed is AC powered, so I'm going to plug my SSR in here. It is polarized. You want your positive on this side and your negative over here. So basically the board's just going to tell that solid state relay to turn on and off. And then on your power input, your negative is over here on the outside of the board. And then your positive goes right here. And then we're good. Now is the time to double and triple check all your connections before you power on. You don't want to short anything out. Make sure all the polarity is correct, all the plugs are in the proper location. And if you're confident, go ahead and power on. So we've powered on and nothing has exploded yet. You want to make sure in main cell or fluid that your printer is responding. We are good. We're seeing temperatures. So at least I know I have a couple of the plugs in the right place. So we can continue on with our printer configuration. So hardware-wise, we should be good to go. The board is up and connected. But one thing I want to remind folks, if they're going to swap out a main board, if you don't like crimping JST style connectors, this might not be the project for you. A lot of these boards use that same style connector, and it can be very challenging if you don't know what you're doing to get those connectors just right. Now, if you're converting from another style of board, maybe a big tree tech board, it's probably not that big a deal because they share a lot of the same type of connector. You can probably just swap them over. But if you're coming from something like a Duet that has a completely different connector base, it might be a bit of a nightmare to get that converted over to one of these boards. Just keep that in mind if you're going to do a project like this. Now, let's jump into that Printer.CFG file and see what we have to do to get this thing up and running. Here we are back in Fluid. Now, we have to do a lot of updating to our Printer.CFG file to get it tailored toward the 3D printer we're installing it on. Now, this is the SK-Go. It's Core XY. It only has 4 stepper motors, so it's a fairly straightforward configuration. It uses lead screws, has a heated bed, but nothing out of the ordinary. So it should be a pretty good use case for a base install for Klipper. So we're just going to start by going to configuration. Again, we're using Fluid today. Printer.CFG. This is the default CFG file that you get with the MKS board. This is the one that's installed. It's running right now. If you have another printer that you want to install with Klipper, the best thing to do is to go get an example configuration. I've said this before, but head to the Klipper Github, go to config, and find a .cfg file you can rename to printer.cfg that's closer to the printer that you want to use. The more work you can do with an example, they've already done it for you, the better off you're going to be, because it's not that straightforward. So pick one that matches your board, or at least close to your printer configuration. These are all also available in the config directory on your Linux install. Anytime you install Klipper, those are going to be there. So it's built into that install already if you need them. These are the ones that are the most up to date, of course. So back to Fluid. We do have this example, which is great, but we're kind of doing this the hard way. And that's because I want to show you how all of this works. So right out of the gate, we've got to do some things before I can even start testing to show you how things work. So since I'm the one doing this, I'm going to tell you exactly what I would do. I've already got it configured. I've got it cabled up. I don't have any errors. And Klipper is really good about giving you an error, trying to tell you what's wrong with your configuration file. You can just kind of keep beating your head on this, honestly, until it works. But what I would do is I would just go to your dashboard and I'd hit Home X and Y. It's always good to have your finger on the power switch, or at least this emergency stop button over here in case something bad happens. So I'm going to switch to this screen so you can see what the printer is going to do, and I'm just going to hit Home XY. The printer already shut down because there's some statements in there it doesn't like. And that's because the configuration that we're using, they've configured all of those stepper drivers for us. We're only using 4. So let's go in and do some cleanup, and then we'll come back and try it again. I know this isn't the most straightforward process. I'm just trying to show you what I would do to get this configured, because I don't know anything about this configuration file. So let's just scroll on through. We've got our X stepper, our Y stepper, our Z. That all looks good. We've got stepper Z1 down here. So you have a stepper section and then you have a driver section. Okay? So Z, we already have the stepper configured, but we don't have a 1, 2, or 3. We don't need any of those. If you'd like to use those at some point, you can leave these in here, or you can just delete these statements. If you want to just comment them all out, that's fine too. Just put in a £. So that's going to take care of that error. We don't have any of those drivers. So let's just scroll down a bit and see what's in here. They've already commented out all of these extra extruders because they used them as Z's. You don't have a heat bed. We'll take care of that in a second. I'm just looking for anything that's going to stop us. Here's your driver section. We have an X, Y, and Z. That is true. But we don't have Z1, Z2, Z3. So again, we don't need them. We're going to comment these out. We're good there. We do have a driver for our extruder. That's where we plugged it in. The rest of those are commented out. This is for 2130s. Again, you could delete it or leave it. It's up to you. Probably don't use a 2130 a lot nowadays. And we don't have a lot of this other stuff, but it's not going to hurt us. It's not going to keep us from compiling or changing our configuration up. So, with that, I would save and restart. You're going to be seeing that a lot today. After the restart, the host came back up. It noticed a problem with that printer.cfg. It has quad gantry leveling. Well, we don't have all of those Z drivers to do that type of leveling. So, back to printer.cfg. You can see that quad gantry at the very bottom, since that's where we were last. It takes up where you left off. We don't have that. It has it in our G32 macro. I don't use it. I'm going to remove it. Just in case you run that G32 for your bed mesh, it won't run that quad leveling. And then we'll go up a bit. Quad gantry level. We can comment all this out. We will want to do bed mesh level, but we'll do that here in a moment. The only other thing I would check in here before we do another save restart is the printer objects here. Make sure it does say the correct kinematics. We are doing Core XY today. These velocities and accelerations are way too high for what we're going to do with this printer. So I'm going to lower velocity to 200, max XL 2000 is more than enough for me. XL, decel, one of these is traveling, one of these is printing. 2000 is good. Z, it doesn't matter to me. We should be good with that. But just while I was here, I'll go ahead and edit that. And we'll save and restart. Looking much better this time. We don't have an error. If you go to dashboard, it's reporting the temperature, so we're good. Now with those edits, we've cut it down a bit. Let's go ahead and try to home X and Y again. It's lowering the bed, that's good. We're going to the left for X, and I'm going to hit emergency stop. Now, you might have expected that or not, but we're using sensorless homing. We don't have end-stop switches, and we don't have that configured. Again, I'm just trying to walk you through this, just to show you step by step how I would figure these things out. Back to Printer.CFG. Now, sensorless homing, I'm going to do another video on this. I will have it available for you to walk you through all the details of it. I'm going to hit it very quickly in this video. Basically, we have to fake out the physical end-stop to use a virtual style end-stop, and then configure that driver to tell it how sensitive the homing needs to be. So we have sensorless homing on X and Y. The first thing we're going to deal with is end-stop pin. Right now, it's just pointed at a pin on the board. Remember this, PA14. We need to use sensorless, so we have to point it at a virtual end-stop. So we're going to paste in TMC2209 underscore stepper underscore X colon virtual end-stop. That tells the configuration that it needs to go someplace else, this virtual end-stop, to get that feedback that it needs to be able to stop. And then when you're doing sensorless homing, I highly recommend homing retract distance. After it homes, it touches again, it comes back and touches again. Set that to 0. That can really mess up sensorless homing. And then we'll just go ahead and do Y while we're here. Remember, we had PA14, this is PA15. We're going to do the same type of thing. TMC2209 underscore stepper underscore Y colon virtual end stop. And again, retract distance 0. Now we're going to scroll down to the driver section. We have our 2209 section here. Remember, we had that jumper on the board. I call them diag pins. When you put that on, that redirects it so that you can use it without that end stop pin. But we have to define that. So our diag pin underscore pin colon, that is the same pin that our physical end stop was on. The first one was PA14, that's for X. And while we're here, let's go ahead and set up diag underscore pin for Y, and that was PA15. Then you need this statement. For a 2209, different drivers, it's different. Again, I'll do a more detailed video on this, but this is the sensitivity. I leave this note in here because I always forget. 255 is the most sensitive, 0 is the least. If I were you, I would start at 100 and work from there. I found on this one, 110 for X is good. We're going to do the same type of statement here on Y. I found 130 is good. Even though it's Core XY, it has more or less weight to push in one direction or the other, so these settings might be different. So that's sensorless homing. We'll save and restart. We'll go back to the dashboard, and we'll hit Home XY again. The bed moves down. X is going to the left. That's correct. It did stop. Y tried to move, but it also stopped. So it's probably too sensitive. But before we go adjusting that, we probably need to look at some of the other motor settings because those play into that as well. But we know now at least sensorless homing is stopping the axis where it needs to go. So back to Printer.CFG. So now at least I can test the movements. Sensorless homing's working, it's stopping where it should be. That doesn't mean they're accurate. The next thing I would look at is microstepping and rotation distance. Rotation distance, they don't do it by steps like they do in Marlin. You have a bit of a math problem to work out. For a belted system like this, Core XY, it's pretty easy. Rotation distance should equal belt pitch times number of teeth on the pulley. You can see we have a 40 here. We've got a 2 millimeter, this is a GT2 belt, 2 millimeter belt times a 20 tooth pulley. That's 40. I actually run a 16 tooth pulley on this machine. So 2 times 16, we know what the answer is, 32. So rotation distance for both X and Y is 32. We'll go ahead and update both of those. And I'm going to go ahead and save and restart. Just with that changes how those motors operate, how much it has to turn to move a certain amount. That might be enough to get it working properly. So do this iteratively, right? Make some changes, do some tests. Home, let's do home X and Y one more time. Z goes down, X is moving correctly, it stops. Now Y is moving correctly because we made that change. It stops. So we're getting there. Next thing that I would test, can you manually move left and right with your buttons here? Notice we're at X230, Y230. We should be at 0, 0. That doesn't look right. So if we move to the right, we're already at max. If we move X back, we're already at max. So these are flip-flopped. You could probably operate this way. You might end up with like mirror mode or something like that, but we want it to be correct. So back to Printer.CFG. So what I'm going to do, since it thinks it's already at max, we're going to change where the end stop is. So I'm going to take out position minimum. That makes more sense when your end stop is at maximum. We're not going to need it for this configuration. We're going to let the position end stop statement tell us where our minimum is. And that is 0. Our end stop is 0. And same for Y. Position minimum, I'm going to remove it. End stop, 0. Now, it's always going to try to move towards the end stop. So it thinks that it's at the end stop at 230. So now it's going to try to take off in the other direction. To compensate for that, I just flip the motors. So the direction pin for X, I'm going to make it move the opposite way. Exclamation point will flip-flop that. I just removed it. And same for Y. I'm going to take off the exclamation point. It'll move in the opposite direction. Now if we save and restart. Oh, I forgot one thing. Invalid homing positive direction. Back to CFG. If you make that change, like I was just saying, you actually have to change this positive dir to false on both sides. So it will go to the minimum. Now we should be good. Save and restart. Now we're back to clean, no errors. Move the print head so we can see it move at least. And we'll hit home XY again. Z goes down. X is going to the left like we want it to. Y is coming to the front like we want it to. We're stopped at the minimum position. You can see it right here, X and Y, 0. If we move to the right, it's moving the correct direction. If we move towards the back of the machine, it's moving in the correct direction. So we're getting there. We've made great progress. The next thing we need to be able to do is home Z. So back to Printer.CFG. We don't have an end stop for Z. We have a probe. Now in this configuration, they're using a gear ratio. Like you had a gearbox. You had something on a belt or a worm drive or something for your Z. And this configuration probably does. It had a couple of steppers that did balancing, all of that. That's probably the configuration they were using. We don't need that. We just have 4-start 8mm lead screws. So I'm going to take out gear ratio for Z. We are using a 1.8 degree stepper, so that is 200. That's true. Rotation distance, that's a calculation as well. It's much simpler, but you do screwed pitch times number of separate threads. This is a TR 8x8, so the pitch on it is 2. But it has 4 starts. Times 4, it's 8. So 1 revolution moves at 2 millimeters, but it's doing 4 times the work. So this setting would be 8. And the end stop pin is already set to probe pin Z, not an end stop. So we know they were utilizing a probe, we just have to get it set up correctly. We should have the right direction because we know the bed does move down when we try to home, which it should. So let's move to probe. The probe pin is currently PB15. We put our probe in the Z-min end stop. So it's going to be real handy to have your schematic available. Remember, that's available over on the MKS Github. But here's the pin out. So our end stop pins are down here. This is X, Y, and negative Z. Right here, PB15 is the negative Z. That's where we have our probe plugged in. This is a 5-volt probe. If you wanted to use the voltage in, 24 or 12 volt with your probe, you can use these over here. They're not 5 volt. They'll take the input voltage. So if you have a probe that has different voltage, be mindful of that. There are ports for it. But we're on PB15, so that probe pin should be good. Now our offsets, you can configure that. I'll show you how. But the main thing we're concerned about is the logic. Right now they have it flip-flop with that exclamation point, but it should be able to use it just like this to stop the Z from moving up. So we should be in fairly good shape. Let's save and restart. And I'm just going to do home all. You can see that it doesn't move towards the center of the bed because the area of the bed isn't the same size as the printer we're using. We're going to fix that. But also the bed just moved down and we got an error. The end stop thinks it's triggered. So that probe being flip-flop is not the correct way to go. It thinks it's already triggered. Printer.CFG. That probe, we're just going to take that exclamation point off of it to reverse the logic. Save and restart. And we'll home all again. Now it's moving up towards the probe as it should. And the probe has stopped the bed from moving. So now we're able to home Z. Next, let's set that bed area to where it should be. So I'm going to home X and Y one more time, not Z. Now for this printer, you can see that X, here's the nozzle, we're right on the same line as X. We should be able to get to that bed. But it's a lot further forward in Y, so we have to add some negative space here. We have to get a certain amount of millimeters before we can even get to the print area. So that's the number we need to know next. I'm just going to jog the printer slowly to get to a safe space where I think it should be able to print on the bed safely. And 33 looks like a safe number. And just remember that. We had to get about 33 millimeters to be able to get to the print surface. Now this bed is a 300 by 300. So let's go back to Printer.CFG. We'll scroll back up to the X and Y motor settings. So X, we don't have to do any extra movement to get to the bed surface. We can print right at 0. So that one's easy, 300. Now Y, we have that 33 millimeter. Now, there's a better way of doing this. This is the quick and dirty way. We can go into this more involved with some of these other settings to show these negative values, but you can't show it on the position end stop in negative. So to be able to get the maximum amount on my bed, what I do is just tell the max position. Remember, we have a 300 bed. Well, my max position is actually 333 because I had to travel 33 millimeters to even get to that 300 bed, and then I have 300 to go. This is just how I do it. Again, it's quick and dirty. Well, I'll show you on the probe offsets here in a moment how that changes it up just a little bit. But again, there's better ways of doing it. We're going to do it this way today. And we're also going to update Safe Z Home because now we know. We're just going to take half of those settings. So X, we punched in 300. So 150. And then Y, we had 333. Let's call it 165. They don't have to be super accurate. We just want it close to the center of the bed. So we'll save and restart. Now, when we home all, the nozzle is much more centered in the middle of the bed. Next up, thermistors. We're down in the extruder here. By default, this configuration has the normal 100K thermistor. This is the very common one that you see. I use an E3D thermistor on this one. So basically, I just had to Google what Klipper calls that E3D thermistor and paste it in here. It's the ATC Simatech 104 GT2. There's a lot of different thermistors out there. Hopefully you can find an entry that is close to the one you're using. PID tune, you're going to have to run that. They've ran it for whatever hot-end they had on this printer. It's very easy to do. I have a video on it, link in the description. But you're going to have to do that before you print. Also, our heated bed, we're going to take the comments off of these. Remember, you can't have a space in the title. It's not going to work. But delete all the comments. Again, you're going to need to run PID. The bed I run does have the generic 100K thermistor, so we're just going to leave that alone. But now we'll have the heated bed. While we're here in the fans, remember I used fan 0, that's the part fan, usually by default, and then fan 1 for the hot end. We have pin PA2, PA1. Have your pin out or your schematic handy. Here's our fan pins here. Fan 0, part fan, PA2. Fan 1, hot end fan, PA1. So our fans are configured correctly. We don't have to do anything. There's a couple of other settings you can use, like setting it at a certain temperature, but this is going to work just fine. It's going to keep the fans off when the printer's not working and then turn them on as needed. So save and restart. So now on the dashboard, we have our extruder as well as our bed. Let's jump the extruder up to 215. We'll hit enter and make sure it's working. And 60 on the bed. And everything's heating like it should. While we're up to temp, now is a good time to make sure the extruder is turning in the correct direction. So let's just hit extrude and see what happens. You can see the filament on top of the Titan there. Hit extrude, and it's pushing it in the opposite direction. So no, it's not going the correct direction. Back to Printer.CFG. So the dur pin on the extruder, we're just going to take off the exclamation point. Now at least it's going in the right direction. Now, what about E-steps? This can get really complicated with the gear ratio. Now, a lot of this information is available. This is set up for the Bondtech extruder. I'm so used to doing E-steps like in Marlin, I usually just configure it for the E-steps that I know. So on my SK Go, I had it configured for 402 E-steps. This is a Titan clone. So to get it into Klipper, I usually just use the math for the E-steps that I know, and then I use a ruler to calculate E-steps. I have a video on that. It's very easy to do, but that's how I fine-tune it in. But just to rough it in, I don't even use gear ratio. You can if you want to, but you've seen these extruders advertised as 3:1, 5:1. That's not the ratio that they mean here. That they take into account all the different teeth involved in all the different parts of the extruder. It's just a little bit too complicated for me. So what I do is I take the full steps per rotation, which on a 1.8 degree stepper is 200. And then I multiply that by the micro steps I'd like to run at, which on this one it's 16. 3,200, and then divide that by the steps per millimeter that I had in Marlin. So I was at 402. So 7.96 is the rotation distance close enough to where I had it configured and calibrated in the Marlin firmware. I know that's not the best way of doing things, but that's how I get it done quickly. So a great place to start for something like a Titan is 796. Remember, you're going to have to fine calibrate this later. This just should be the starting value. So our extruder, hot end, all that should be roughed in. We should be able to print with that. Maybe not well, but it will get us up and running and we can start fine tuning. The only other thing we need to tackle before we can start to print is our bed leveling. This printer does have a probe. We want it to automatically level the bed based on a mesh, just something simple. So we're going to add that in. So go back to configuration, Printer.CFG. And you can put it pretty much anywhere, but I'm going to put it down here under probe. And I'm just going to paste in the bed mesh configuration I usually use. Again, we have bed mesh. Speed doesn't matter too much. How much do you want Z to move up? And what are your mesh minimums? So remember I said that 33? That's how much it takes Y to even get over the bed. So I put mesh inset about 35. Again, we can start probing at 0 of X. And then the maximum's 275 on X. You have to allow for the carriage. The probe is on the left side on the SKGo. And then 300 in the back. You probably want to play with these values just to see how far you can build the mesh. But these are pretty much the limits for the SKGo. And then the probe count, this is X and then Y. So I'm just doing 3 on the front, 3 across back for a total of 9. So this will enable us to create a bed mesh. We do have to calculate the probe offset. That's these values up here. I'll show you how to do that real quick. So you can get your probe offset in a couple of ways. You could just get your ruler out and measure from the tip of the nozzle over to the probe, front and back, and try to get some measurements. But you can also do it kind of tricky by putting some tape down and then drawing where the probe is. That's the method I'm going to show you now. So I'm just going to put some painter's tape on the center of the bed. Then I'm just going to home all. Because we're using safe homing, it's going to put it in the center of the bed anyway. After you home, if you don't have safe homing, just jog it to the center of the bed, relatively close. The tape shouldn't affect your probing. Then I'm going to go to the console here, and I'm going to enter probe. It's going to take one probe. Then we're going to do get underscore position. And we're just worried about the tool head position. So record this one. Then we're going to go to our tape and our probe. I'm going to take a Sharpie. Shouldn't hurt the probe to get a little ink on it. But I'm just going to draw on the tape around my probe. So I have a little bit of a circle there where the probe goes. Now I'm just going to use my controls to jog it so the nozzle is in the center of that circle that I just drew. And then when you're happy that the nozzle is in the center of that circle where the probe was, we'll head back, go to the console, and do another get position. You just hit up arrow, and we'll take the tool head position once again. So now all we have to do to get our offsets for X, we're going to do the nozzle position, 124, minus the probe position, 150. Our offset for X is negative 26. Then Y will do the same thing. Nozzle position, 171, minus 165. Positive 6. Back to Printer.CFG. X, since the probe is over there on the left, it's negative 26 from the nozzle. And then Y, it's a little bit behind the nozzle. So positive 6. And your Z offset will be set by the paper test. I go through that in the Klipper auto bed leveling video. I will leave a link to that exact point in the video where you need to calibrate that offset. The only other thing I suggest you do is make sure your configuration has a start print macro. You can see cancel print, pause, resume. Start print, I use Prusa Slicer. By default, if you use the Klipper or the Voron printer profiles, they're going to expect you to have start print. Basically, it's just a macro that tells it to home before the print starts to fire up. You can put anything in there you like, but in Prusa Slicer, you don't need a whole lot. Here's what mine looks like. This is a great place to put your purge line. This isn't configured for my SK-Go, but this is the place where you'd like to put it. I might have said start print, but it's print_start. So when the slicer runs that, it knows what to do. Mine's just going to home. If you don't have this and you try to run it, it's going to be an unknown command. But just know, a lot of slicers are going to have this in there, and they're going to try to run it at the beginning of Klipper prints. Just for example, here's a Voron profile in Prusa Slicer. If you go to Printer Settings, Custom G-Code, there's that print start that I'm talking about. After you set your offset, really all you need to do is run a bed mesh calibrate, because we do have a probe and we have a bed mesh. We want it to compensate for any bed inconsistencies. We'll run that calibrate. We set it up to probe those 9 points, so it's going to get that done. If you have any errors, it's probably because your probe is out of range. So you might need to adjust those numbers in the mesh that we created. When the probing has been complete, if you go back to console, it's going to want you to save the config. This will save it to your Printer.CFG. It'll restart Klipper. If you go to Printer.CFG, you can see it here at the bottom. The bed mesh is default. And if you want to make sure that bed mesh gets loaded every print, that's something that I would put in print start. So I'm just going to copy this in here, bed mesh profile, and we just want to load it. Space load equals default. That will just ensure bed mesh leveling is in play during the print. And our last and final save and restart. With all that, we have the bare minimum here. We should be able to go ahead and take our printer for a test drive. Remember, make sure you did that paper test to get your nozzle height correct. I'm just going to kick off the Benchy print. You're going to see it start to heat the bed. After that gets done, it's going to start heating the hot end, and it's going to run that start print script. While it's heating up, you can take a look at some of these tune features. You can see our bed mesh map. Not the best one I've ever seen in the world, but we do see that our default mesh is active. So that's good. And our Benchy is off and printing. Not the best first layer so far, but the machine is functioning. So we're a couple layers in. It's not the best print I've ever seen. I didn't think it would be. This is just a very rough configuration. Looks like we're a little hot. Have some work to do, but it does print. So there it is. We are finally up and printing on our MKS Skipr board. I've said this many times, but this is just a rough configuration. This should be enough to get you up and printing, but probably not that well. Again, I do have other videos on some more detailed subjects like bed leveling, as well as centerless homing. And you want to pay attention to your slicer settings. Again, these were very rough just to get you up and going, but how the slicer treats Klipper is just a little bit different. And maybe we need a follow-up video on that as well, just so I can show you the tips and tricks that I do to get my Klipper installs to work as good as possible. So hopefully all this was helpful. You can use it on your Klipper install. That will be it for today, and I'll see you really soon on the next one.